Hey y'all, I hope the awesome weather's putting you in a good mood to review discounting. In this video, I'm going to ask you 3 questions. I'm going to go over a little numerical table, and then I'll circle back to the beginning by summing things up. First question, why discount? The simple answer is we want a common yardstick to measure costs and benefits that occur at different points in time. What do I mean by that? A dollar received 50 years from now is not the same as a dollar received today. It's not an apples to apples comparison. It's really important when we conduct the benefit cost analysis that we're putting things on equal footing. We want an apples to apples comparison. That's why we discount. If that's not a satisfying answer to you, let's ask another question. Would you prefer $100 today or in a year? If you're smart, I'd argue you'd say today. Why? You could invest that $100 and have $105 in a year, assuming you put it in an investment that had a return of 5%. That is, we discount because of the time value of money. If I just received that $100 a year from now, I'd be foregoing the time value of money for the current year, because I could invest that money, that $100, and in a year have $105. But by foregoing that time value of the money and receiving my $100 just a year from now, well, I'm left with $100 instead of the $105 if I had taken the money today. Okay, so maybe that's still not a satisfying answer to you. Let's think about discounting in the following way. We can think of, here, let me get the, there we go. We can think of discounting as compound interest in reverse. I think many of you are familiar with how we calculate a future value. So let's ask the question, what is the future value of $100 invested at 5% annual interest rate for 50 years? The formula for that, well, we have our future value in year t. It's going to be the present value multiplied by 1 plus the interest rate, r, raised to the t power. So if we have $100 at a 5% interest rate, well, compounding that interest over 50 years, we're going to arrive at $1,146.74. Applying the concept in reverse, that must mean that $1,146 is only worth $100 today. Because if I invested that $100 today, I'd get that $1,146 50 years from now. We arrive at the formula for present value in year t. It's simply the future value in year t divided by 1 plus, in this case, we maybe think of it as the discount rate instead of the interest rate, raised to the power t. Notice, it's just some simple algebra. I've taken 1 plus r raised to the t power and divided both sides by it. That's how I get the present value divided by the future value in year t divided by 1 plus r raised to the t power. If we look at some standard text on benefit cost analysis and discounting, maybe even in your class notes, we replace that future value in year t with the net benefit in year t. That's the way we think about it whenever we're conducting a benefit cost analysis. There are benefits received in each year of the project. There are costs that are borne each year of the project. If we combine those, we get the net benefit in each year. What we want to do is bring the net benefit in year 2 back to now. The net benefits in year 3 back to now. The net benefits in year 50 to the present. That is back to now. Hopefully by now you're getting the sense of how discounting works. What I want you to notice next is how the discount rate is going to influence the present value of some amount of money received in the future. To make our example concrete, let's think about the present value of $1,000 received in T years. What we have here are different discount rates, 1%, 3%, and 7%. Here we have the number of years out to when we receive the $1,000. This is receiving $1,000 in 10 years, this is receiving $1,000 in 50 years, and this is receiving $1,000 in 100 years. How to read the table? What is the present value of $1,000 received in 10 years if we assume a 1% discount rate? A 1% discount rate applied to that $1,000 in 10 years results in a present value of $905 in present value. If we receive that $1,000 in 50 years and apply the same 1% discount rate, so we'd have 1,000 as our net benefit, 1 plus 0.01 as the denominator raised to the 50th power, then we're going to get $608. Finally, if we invest that $1,000, we receive that $1,000 in 100 years, applying the 1% discount rate, that $1,000 received in 100 years is only worth $370 today. Moving on to the second row, we're assuming a 3% discount rate. So we have a higher discount rate. A higher discount rate means exactly what the name suggests. We're discounting at a higher rate. That means we are taking it less into account. We're discounting it. To see how it works, $1,000 received 10 years from now with a 3% discount rate is only going to be worth $744 in present value terms. $1,000 received 50 years from now at a 3% discount rate is only going to be $228 in present value terms. $1,000 received 100 years from now is only going to be worth $52 if we apply the 3% discount rate. Finally, let's consider the 7% discount rate. $1,000 received 10 years from now, applying the 7% discount rate is going to be worth $508. $1,000 received 50 years from now, applying our 7% discount rate is going to be worth $34. Receiving $1,000 100 years from now, applying our 7% discount rate is only going to be worth $1. What this table illustrates is that when we have a higher discount rate, we're placing less value on the future. We're placing less value on future benefits. When we have a lower discount rate, we're placing a higher value on the future. If we have a 0 discount rate, that means we value the future exactly the same as today. One of the arguments for a 0% discount rate is that we shouldn't value the welfare of future generations any differently than the welfare of people today. To make another concrete example, should we value a lost life 5 years from now any different than a lost life today? A lot of us would agree that we shouldn't put a different price sticker on those two lives. Finally, we're coming to part 5. This loops back to why discount. We want a common yardstick to measure cost and benefits occurring at different points in time. The net present value converts benefits received in some future period t and sums them all up. We're able to sum them up because they're all put into their present value terms. If you're not familiar with this formula or this notation, we could also write this as the present value of the net benefit received in period 0 plus the present value received in year 1, the present value of the net benefit received in year 2, and so on and so forth until the final year of the project. Before I check out, I want to direct you to page 31 to 33 in Markets and the Environment by Keohane and Olmsted. This summarizes this. It's a short 3 pages. Read it. You can find it on Canvas. Have a great night.